welcome you for the online class. Myself, Dr. Babu. I was working as an assistant professor in the Department of Electrical and Electronics Engineering at the University Surampalem. Second module in Unit 1. It is of analysis of balanced three-phase circuits and measurement of active and reactive power. So, welcome to the recap. In order to start this session, we should be knowing about some important topics from the previous session. So, first one is some of the important points that we have discussed in the previous class regarding star connection. So, first one is star connection and will be followed by delta connection. So, coming to the star connection, as we have discussed, the line voltage is equal to root 3 times of phase voltage. This one we have already derived the equation in the previous module. And the second one is regarding the currents, line current is equal to phase current. And coming to the power is equal to root 3 times of VL IL cos phi. That means VL is line current, line voltage, IL means line current, and whereas cos phi means the power factor. And coming to the reactive power, here reactive power is root 3 times of VL IL sin phi. Here also VL means line voltage, IL means line current, and sin phi is the phase angle difference. And coming to the apparent power, it is equal to root 3 times of VL IL. And the final most important point is the potential at the star point is, that means the voltage that is the combining of all the neutral points, that means VNR, VNY and VNB, that means the phase voltages with respect to voltages, that and its sum is 0. And coming to the delta connection, the line current is equal to root 3 times of phase current, whereas in star line current is equal to phase current, and in delta connection line current is equal to root 3 times of phase current. In terms of voltages, line voltage is equal to phase voltage. And the next one is power, which is nothing but real power, reactive power and apparent power. So, real power here is also, its equation is given by root 3 times of VLIL cos phi, which is similar to the real power equation in star connection. Second one is reactive power, and here also the reactive power is root 3 times of VLIL sin phi, which is similar in terms of star connection. The apparent power equation is root 3 times of VL into IL. Okay. Now, here in this session, we are going to solve two numericals regarding one in star connection, another one is in delta connection, and also we are going to solve these numericals in balanced load. Okay. So, in the previous session I have stated that balanced load in the sense the impedances in all the phases R phase, Y phase and B phase is equal. So, if you look into this numerical, first we will go to the numerical, and the example is a balanced star connected load of 8 plus j ohms. That means here they have given the impedance Z is equal to 8 plus j times of 6 ohms. Okay. And this per phase and is connected across a 3 phase, and the supply voltage is 230 volts. So, supply is 230 volts. We are supposed to find line current value, that means IL, and power factor, that is cos phi, and power, that means active power, reactive power and apparent power. 3 powers we are supposed to find it over here. Okay. So, if we draw the equivalent circuit diagram for this, here it is, we have already drawn it here, you can observe it from here. In all the 3 phases, that means impedance as it is balanced, ZRN is equal to ZYN is equal to ZBN, which is nothing but 8 plus J6 ohms, because in balanced condition the impedance is same in all the 3 phases. Okay. Next one is in the numerical they have given 230 volt supply. That means this is our balanced star connection, let it be load, and is getting supplied from the another side, that is supply side. Okay. That means here the voltage across the phases is 230 volts. Okay. That means here you can simply call it as line voltage is equal to 230 volts. Okay. Here line voltages are V Ry is one line voltage, that is nothing but 230 volts, which is equal to another line voltage V. Ry is completed. Next one is here it is written ABC. Okay, Vry is 230 volts and Vby is equal to 230 volts at an angle of 120, and Vy Ry and Rb, Vrb is equal to 230 volts at an angle of 240 degrees. Okay, let me write it again clearly here. Vry is equal to 230 volts at an angle of 0, and Vry Yb is equal to 230 volts at an angle of minus 120, and Vbr is equal to 230 volts at an angle of minus 240. These all are in volts, and which are nothing but these all are line voltages. Okay. So, in the problem they have given the impedances, that is Zrn, Zyn, Zbn. They have given the impedance 8 plus j6 ohms and voltages they have given. So, in the numerical they are asking us to find out the values of line currents IL and power factor, which is nothing but cos phi, and power, that means active power P, reactive power Q and apparent power S. Okay. So, in order to solve these things, first we got the line currents, line voltages. Now, we are supposed to find out the line voltage, phase voltages. So, as per the numerical, as per the star connected load, we all know that in star connection, line voltages is equal to root 3 times of phase voltages. This one I have stated here, you can see it here. Line voltage is equal to root 3 times of phase voltage in star connection. So, from this I can calculate the values of Vrn, Vyn and Vbn, right. Therefore, now here I am calculating the values of Vrn, Vyn and Vbn. Okay. Now, Vrn is equal to what is the value of Vrn, which is nothing but phase voltages. Phase voltages are line equal to root 3, line is equal to root times VL by root 3, that is nothing but Vrn divided by root 3, Vry divided by root 3, which is nothing but 230 at an angle 0 by root 3. Here the value will be 132.8 at an angle of 0 volts. Next one Vyn, its formula is also VL by root 3, this one is Vyb by root 3, which is nothing but 230 at an angle of minus 120 divided by root 3. It will be around 132.8 at an angle of minus 120 degrees. Next one is Vbn. So, here Vbn is equal to nothing but phase voltage, that is equal to 1 by root 3 times of line voltage, that is equal to Vbr by root 3. Here it is equal to 230 at an angle of minus 240 divided by root 3. Here the value will be 132.8 at an angle of minus 240 degrees. Okay. So, here I have found out the values of phase voltages. I got this phase voltages from the line voltages, which is nothing but line voltage is equal to 230 volts. From this value, I have obtained the values of this Vrn, Vyn and Vbn. Okay. Now, here what I was supposed to calculate? Here they have asked us to calculate the values of line currents. So, in order to calculate the values of line currents, we all know that voltage is equal to current into impedance, right. Therefore, impedance is equal to voltage, current is equal to voltage by impedance. So, here see, let this be line current or phase current, okay, and this side will be R phase and this will be Y phase and this will be B phase. Therefore, IR is equal to See, the voltage will be, what will be the voltage across here? VRN divided by ZRN. Okay. Here in the previous case we have calculated the VRN. The VRN value is 132.8 at an angle of 0 degrees by the impedance value is 8 plus j6 ohm. If we calculate this, the value will be approximately 13.28 amperes. Okay, this is the phase, this is the line or phase current in R phase. Similarly, we need to calculate the values of IY. That means the phase current of passing through Y phase. Here IY is equal to VYN by ZYN, which is nothing but 132.8 at an angle of 120 minus 120 degrees divided by 8 plus j6. Here it will be around 13.28 at an angle of minus 120 amperes if we calculate. Next one is IB. Here IB is equal to VBN divided by ZBN. That means the current flowing through this B phase. Here the voltage value is VBN and the impedance value is ZBN. Therefore, here it will be 132.8 at an angle of minus 240 degrees divided by 8 plus j6, which is nothing but 13.28 at an angle of minus 240 degrees amperes. So, therefore, from here I got the values of line current, I have got it. So, the current through R phase is 13.28 and Y phase is 13.8 at an angle 240 and Z phase is 13.8 at an angle minus 240. Now, we need to calculate the values of power factor and power. Okay. Here the impedance value is 8 plus j6 ohms. Okay. Therefore, if I draw the impedance triangle over here, this will be 8 and this will be 6 and this will be 10 ohms, right? And here it will be the phi. For cos phi is equal to 8 by 10, which is nothing but 0.8. Therefore, power factor is equal to 0.8. It will be almost anytime it will be lag itself only. So, like this we can calculate the value of power factor. Now, coming to the power, now I am concentrating on real, let me erase it properly. I am concentrating on real power. Real power is equal to root 3 times of VL, IL, cos phi. Okay. Root 3 we know, VL value is 230 volts, and IL value is 13.28 and cos phi is 0.8, right? Root 3 times of VL, IL, cos phi, which is nothing but root 3. The value of VL is 230 and IL is 13.28 and cos phi is 0.8. We need to calculate it and write down the value of active power, real power. And the next one is reactive power, which is noted by Q. Here the reactive power value is root 3 times of VL, IL, sin phi. So, we know the value of root 3, VL value we know 230 and IL value is 13.28. Here cos phi is 0.8, that means sin phi will be and it will be 0.6. Okay. Now, calculate it and note down the value. Next one is apparent power S. Its value is given by equation value is given by root 3 times of VL, IL. Therefore, it will be root 3 into the value of VL is 230 and the value of IL is 13.28. So, write it, note down the values. So, like this we can calculate the values of line currents, phase currents, line voltages, phase voltages, power factor and power. Okay. I think the numerical regarding the star connection is clear. Now, I am moving on to delta connection part. Okay. Now, you can observe this part here. I have taken the similar problem and here also we have considered balanced load. So, balanced load in the sense impedance is 8 plus j6 ohm, that means ZRN is equal to ZYN is equal to ZBN is equal to 8 plus J6 ohms. Okay, and they have given that is a 3-phase supply. Yeah, we know that 3-phase only, and the source is 440 volts. But here you should be clear that whether it is line voltages or phase voltages, this 440 volts. Now for this, let us draw the diagram part. Okay, let this be R phase and this be Y phase and this be B phase. That means this will be R, that will be Y, and this will be B. We are noting the points like this, and this one is J6 8, J6 8 and J6 8 ohms. So these are the impedance values. The diagram will be in this manner now, and it will be R, Y and B, and he has given that 440 volt supply. That means this voltage across R and Y is 440 and Y and B is 440 and R and B is also 440 volts. Okay. Therefore, ZRY is equal to, sorry, VRY it is, VRY is equal to, VBY is equal to, VRB is equal to 440 volts. That means we have noted down the values of line voltage. In a delta connection, line voltage is equal to phase voltage. Therefore, we have obtained the values of line voltage and phase voltage be 440 volts, but we can write it as a phase displacement of 180 degrees. Okay. And the next part is, I am supposed to find out the line currents. Okay. This is line current IR, and it will be line current IY, and it will be the line current IB. Now see here this part again, it will be IRB and this will be IRY and this will be IBY. Okay. So let me erase this part, and we will be going through the calculation of line currents and phase currents. Okay. Here IR, IY and IB are the line currents, whereas IRB, IYB and IB are, sorry, IRY, IYB and IRY are the phase currents. Now we need to calculate the values of line currents and phase currents. So in order to calculate this one, we all know that in delta connection, line current is equal to √3 times of phase currents. Okay. In delta, line current is equal to √3 times of phase current. So now which one I can calculate here? You can observe this one. See, this means here I know the value of VBR and I know the value of ZBR. So from this I can calculate the values of IRB, right? See, here I am writing it. I think hope you are understanding this part. Here I am calculating only RB phase only, VRB, which is equal to 440 volts. Okay. Next one, ZRB is equal to 8 plus J6 ohms. From this I can calculate the value of IRB. IRB is equal to VRB by ZRB, which is equal to 440 divided by 8 plus J6 ohms. I can make it as approximately 44 amps, this one. Okay. Similar way, I can calculate the values of IBY and IYR. Okay. So from this I got the values of phase currents. Okay, these are my phase current values. Now I got the value of phase current. From this I can calculate the values of line currents. Okay, line current, here I am writing it, line current IR is equal to IRB plus IRY. Like this you can calculate it, or else line current is equal to root 3 times of phase current, right? You can use both the formulas. So if you are using the first formula, means you need to calculate the values of IRY also, or else you can directly go for IR is equal to root times of I phase, which is nothing but root 3 times of 44. Okay. From this you can get the value of line currents and phase currents. Now you are supposed to calculate the value of power factor. Like in the previous case, we can draw an impedance triangle over here. This will be 8 ohms and this will be J6 ohms and this will be 10 ohms, because this is the resultant part, and here lies the angle phi. Okay. Now here phi means power factor angle. Therefore cos phi is equal to 8 by 10, which is nothing but 0.8. This is the value of power factor. Okay. Now I have got the value of power factor. Next left over part is power for phase. Okay. Now power, here also 3 types of powers we will be going to calculate. First one is active power, which is nothing but root 3 times of VL, IL, cos phi, root 3, and in delta connection line current is equal to phase current. So VL is 440 volts. Next one is IL. IL we got it as previously it as 44, and cos phi is in the previous case we got it as 0.8. So we need to calculate the values and write down the value. And the next one is reactive power. Its value is given by root 3 times of VL, IL and sin phi, which is nothing but root 3 into the value of VL is 440 and IL is around 0.44, and if it is 0.8 over here, sin phi value will be 0.6. Calculate it and note down the value. And the next one is apparent power. The formula for apparent power is root 3 times of VL, IL, which is nothing but root 3 into 440 into 44. Calculate it and note down the values. So from this we have calculated all the powers per phase. Therefore, in this numerical we have calculated the values of line currents, phase currents, line voltages and phase voltages. Next one is power factor cos phi, and next one is powers. We have calculated active power, next one is reactive power, and the final one is apparent power. So this is the method we need to follow for the calculation of all the values. Okay. Hope the numerical with the delta connection is also clear. Next, I am moving on to summary for this numericals. So here you have calculated the values of reactive power in the both star and delta connections, and followed by reactive power also we have calculated. Next one, apparent power, S also we have calculated. Okay. So all the power calculations we have calculated. Why we need to calculate the power calculations? Because we need to know what amount of load or demand a particular system is consuming, so that we can install meters. For example, in our household appliances there will be lots of MCBs you can see nearby, ACs, washing machines. Have observed it? I think many people have observed it. MCB will be there near AC, washing machine. That means that ACB is designed for 20 amps. That means the maximum amount of power that can be passed through that through AC is 20 amps. Like that, we are calculating the values of power, voltages and currents, so that an efficient power transmission distribution system can be designed. Okay. So with this we have concluded this session, and in the next module we will be going to start the third module of our class.